Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the last question of this paper, that is question number 45 of NEET Physics paper 2017. Hello students, let us solve question number 45. The resistance of a wire is R ohm. The wire is there, the resistance is R ohm. If it is melted and stretched in n times its original length, this length is increased. Suppose this length is L, now it is n times the original length. Its new resistance will be. So what is this new resistance R dash? This is a direct formula question. This is a very easy question. That is n square R times the answer. But then we'll solve how this is done. This is the old resistance, which is R. The new resistance is to be found when the wire is stretched to n times its length L. Now the resistance of a wire is given by rho L over A, where rho is the specific resistance, L is the length of the wire, and A is the area cross section. So what happens is that when we increase the length of the wire, this was the original wire, so this area cross section will be greater than when its length is increased, because the increase in length will followed by a decrease in diameter. The more you stretch the wire, the more and more it gets thinner. So the area cross section here is suppose A, but here it will not be A, it will be something else. Here the length is something else, the area cross section something else. So what is happening is that the resistance, if you want to find, but then rho value will remain the same, because that depends on the material. Because we are not changing the material, the rho value will remain same, only R varies with L and A. So that is proportional to L over A. This is the relation where L and A both will change, because the length is increasing and also area cross section is decreasing. But in this process, the volume will remain constant. So let me just help you solve the question. During this process of initial condition and the final condition, the volume is constant. Volume initial is volume final. This V for volume of the wire. Initially, the volume of the wire is the area cross section into length, and the final volume is A dash, and the length becomes n times, so NL. From here, L will cancels and A dash will be A over N. Now, the initial resistance is R, which is rho L by A, and here the final resistance R dash is rho will remain the same because not going to change. Length is N times rho L by A, area cross section is A dash, which is A by N, A divided by N. So this is N into an N square, rho L by A, rho L by A. So this is R dash. Now R dash is this, R is this, divide that to R dash over R will become N square rho L by A divided by rho L by A. So these two factors will cancel out and R dash will be N square R. So R dash will be N square times R. This is how you solve. There is so therefore the new resistance is N square times the old resistance. This is the formula actually given in the book. You can directly use, otherwise this is the solution. Another approach is that you want, this is another approach. The new resistance we are interested in, which is rho L dash upon A dash, because rho will change, the length and area will change. Now what is the new length? It is given that is n times the original length. What is the new area of cross section? Because volume is keeping same. Volume is keeping same, so A dash, because A into L is A dash L dash. So from here, that L dash A dash, I just told you that time it is n times L, so A by n. So from here it is A by n. If I put here directly rho L dash is n times L, and this is A by n, so this becomes square, and this rho L by A, n square. Rho L by A is original R, so this way also you can directly do that. Or resistance is proportional to L over A. L is increasing n times and A is decreasing n times. If this decreases n times, this will increase n times, so it will come to here. So n into n is n square. So this is increase in area resistance by n square times. This is the shortest method to solve, but this is the once you do this for the first time, you have to solve all the methods, but then afterwards you can remember the formula. Okay, so this is the answer to this question, that we are getting n square times r. So whenever any wire is stretched along with the increase in length, there is a decrease in diameter, so therefore the new resistance will be always n square times the, that is number of times that increasing the length of the wire, that is n square times r. So this is the answer to this question. Okay, thank you.